Hello and welcome to this Wireshark tutorial series. Before we start digging deep down into all that technical stuff, I would first like to give you a bit of an intro, so that you may have a better understanding of what the course is about and what you can expect to learn from it. Let me just begin by saying that this course is meant to teach you how to effectively use Wireshark to capture and analyze network traffic. A key thing to note here is that the course layout is such that it really does not matter whether you are a beginner or an advanced user. Either way, you will be able to benefit from it to a great extent. And now let's just deal with some questions. What is Wireshark? And what do you use it for? Why should you learn how to use it? Well, Wireshark is an open source program that is used to capture and analyze network traffic. It is a must-have for pretty much every network admin out there. It is a number one piece of software for its purpose. Number one. In the real world out there, on larger scales, it has countless applications, ranging all the way from tracing down unauthorized traffic to confirming firewall settings and so on. I will talk more of this as we continue to progress through the series, but for the time being I just wanted to give you a glimpse of it. If you go on the net and take a look at job postings for network administrators, more often than not, at any of the bigger companies, advanced knowledge of Wireshark will be stated as a requirement, or it will be listed as a big plus. So either way it's beneficial. So if you're preparing yourself to work as a network administrator, this course will undoubtedly be of great use to you. But regardless, even if you are a casual user, it will help you to better understand how your computer, and not only your computer, but all of your devices, your smartphone, laptop, desktop computer, router, switch, etc., how all these devices communicate in local area networks or with the rest of the world. Okay, so before I wrap this up, I would like to make a personal note. As you can see here on my screen, I have Wireshark installed and configured. It is up and running. There is currently a live capture session in progress. This is approximately how our tutorials will look like. This will be our working space. This is where we will conduct pretty much all of our activities. However, if this is your first time that you have encountered something of a kind, it might seem a little bit intimidating, especially if you don't have any previous networking experience. Believe me when I say it is not. If you stick with me, by the end of this course, you will be able to understand everything that is written on this screen and much, much, much more. What I would advise you to be, I would advise you to be curious, as it does stimulate you to mess around with stuff. Although if you do decide to conduct some sort of experiments or something of a kind, I would strongly recommend that you set up some sort of virtual machines, as it does make things a lot easier. And remember, in general, if you wish to learn something, you must be willing to devote a certain amount of time and labor. And in our line of work, more often than not, you will require nerves of steel. In the beginning, things will seem a bit difficult. You will try to solve problems, they won't make sense. It'll be frustrating, but stick with it. Get through the first steps, and things will become a lot smoother as we continue our progression through this course. Now that we got all of that stuff out of our way, we can now begin with our first lesson. In the next video, I sincerely hope that you will join me there. Hello everybody, and welcome to this first tutorial of the series. Here we will review some of the basic concepts in regard to the network traffic. It is very important for you to understand some of the basic terms so that the information that we will later gather with Wireshark can be understood. Keynote here: if you feel that you are already familiar with basic concepts such as IP addresses, MAC addresses, ports, protocols, and so on, you can go ahead and skip to the installation and setup tutorial. Okay then. Most likely, at some point of time, you have heard the term IP address. but you never really understood what it actually is or what it is used for. IP addresses, in essence, were designed in order to make it possible for devices to be able to communicate with one another within local networks or in general over the internet. And that is the primary purpose of an IP address. Aside from that, it can also be used to pinpoint the exact physical location of any device that is using it. Basically, you can compare it to a mailing address. It is unique and used for sending packets. Computers and other devices work on similar principles as your local mail. You specify recipient and sender address, take the letter or packet to the mail office, and send it. Computers pretty much do the same thing, except instead of a street address, they use an IP address. Internet Protocol, or IP as it is more commonly known, is just a set of predefined rules that dictate the terms under which communication shall be conducted. For example, it enables you to browse the web by enabling you to contact a series of servers who also operate on the same protocol. IP addresses consist of 4 numbers, and each of the 4 numbers can go from 0 to 255. The limiter used to separate them is a dot. Here's an example of how it looks like. Now I have my terminal here set up, and I'm just gonna type ifconfig. That's gonna list out all of my interfaces. So I don't know, I have a loopback, which is LO, the first one. I have P8P1, which is my Ethernet connection. I have VRBR1, that's my virtual machine thing. That's for the virtual machines. The one that we're going to be focusing now is VLP2S0, which is my wireless interface. So I'm just going to type just going to clear the screen first, and I'm going to type ifconfig VLP2S0. No, ifconfig VLP2S0. There we go. So it gives you a bunch of information here. And what is what? So we're not interested in most of it, as most of it is of really no use to us at the moment. The part that we are interested in is the INET, so the address, the IP address of the interface. You have 192.168.1.2. So this is basically how it looks like. So 192.168.1.1.2. So each one of these numbers, for example, let's take this 2, it can go from 0 to 255. And you can literally make billions upon billions of combinations with these numbers. Very simple concept to comprehend, and there's nothing too complicated about it. We'll later deal with the interfaces and other things, but for the moment I just wanted to show you what an IP address is and how it is used, where it is assigned, and where you can find it. Anyway, there are 2 basic types of IP addresses: static and dynamic. Most private users have a dynamic IP address, while on the other hand, business users and servers mostly have static IP addresses. Static addresses, once assigned, do not change and facilitate a stable and a reliable way for other devices to communicate with the given server, on which various services are running. While dynamic IP addresses change every time a device connects to the internet or the local network, making it a lot more difficult for anyone to contact you simply because they won't know your address, as it changes quite often. Both dynamic and static IP addresses are provided by internet service providers. Okay, now that we have basic understanding of what IP addresses are, we can move on to ports. Computer ports are in essence docking points for all the information coming to our devices and all the packets that are being transmitted by them. They work in combination with IP addresses directing all outgoing and incoming packets to their proper places. Port ranges are defined and numbered. For example, there are most common ports that range between 0 and 1023, but the numbers go a lot higher than that, so no worries there. You have a pretty big range to work with. Here's a simple list of some well-known services and ports on which they run. So for example, you have FTP, which runs on port 21. FTP is a file transfer protocol, if you haven't heard about it. Also, you have HTTP, which we all use on pretty much daily basis, and HTTPS, same scenario there, except the information on port 443 over HTTPS is encrypted. And we have a DNS, which works on 53. So with the other ones, I'm sure that you've already heard about them or are familiar to an extent, but let me just quickly and briefly say what DNS does. So it basically resolves the main names to IP addresses and vice versa. So for example, google.com would be a domain name. I don't know the IP address of it, but here let me just find out. So we can just do ping google.com, and I'm going to interrupt the ping here. So you have it here. This is the IP address of google.com. Basically what DNS does is resolves this into this, and it can also be used for vice versa pretty much. But enough about this. I will expand on this subject later at the later stages of this at some other point of time during these tutorials when we actually go into the Wireshark, and once we do filters, once we actually start talking about filters and filtering protocols, etc., and so on. But for the time being, let's just keep our focus on the ports. Each individual port range has its particular purpose and will direct all packets in predefined directions. Here, allow me to do a bit of a demonstration here. So I'm just going to clear my screen, and I'm going to show you what ports are open on my computer, what ports am I listening on. So if I just do nmap local host nmap local host, there we go. Just disregard this upper part and concentrate on this one here. So you see it says port, it says 111, state open, RPC bind, that's the service. 631 IPP. IPP is an Internet Printing Protocol. I should probably close that because I have no use of it. But here, I'm going to start my Apache web server, and immediately after that you will see that I will start listening on port 80. So service pd start, there we go, and I'm just going to do the nmap again. There we go. So now you can see that I am listening on port 80, it is open, and the service is HTTP. So all traffic coming to me on this port will be directed here. So you see I have localhost there, so HTTP localhost, and it throws me to this page, to the beginning page of the Apache server that is not configured. Anyway, that's just a bit of how traffic gets directed, and we will expand on ports a bit more later on as we dig into Wireshark, but for the moment I just wanted to give you some basic ideas so that you would have some sort of basic understanding upon which we will later be able to expand. And now we can deal with MAC addresses. MAC, it is spelled so, you see MAC, it stands for Media Access Control Address, and that is a burnt-in hardware address that uniquely identifies not your regular device in terms of networking, but rather instead your network card. Here's a short demonstration. So I'm just going to clear the screen out now. I'm going to do ifconfig, and you can see that there are various interfaces here, as before. So each one of these interfaces has its own MAC address. That is the MAC address of the network card to which the interface is configured. So you see this one is BC8556C6A505. My wired interface is 7486, and so on. So you see each one of these that is used to connect to the internet or something of a kind has its own MAC address, and it is uniquely identified so on the local network, not on the internet, but rather instead on the local network. Anyway, let me just round up this with protocols. Protocol in any system, in general, is just a set of predefined rules that determines how something should be done. In regard to computers, protocols are agreed upon or standardized ways of communication. To give you a real-life example or a comparison, just try to imagine two people trying to communicate. What would they need? Well, for starters, they would need to agree upon which language to use, and preferably when one talks, the other should listen. But as you know, this is commonly not the case. And that would be a protocol. Basically, they agree, okay, you will talk now and I will listen. Then I will speak and you will listen. We will use this language to communicate. And those are the predefined rules that make up a protocol. One of the most famous protocols today, one of the most used ones would be a proper thing to say, is a TCP/IP. TCP stands for Transmission Control Protocol, and IP I have mentioned before, that is Internet Protocol. We will deal in great detail in later tutorials with TCP, UDP, and other protocols of similar kind. But for the moment, I just want to give you a hint of what is to come, and it would be unwise of me to deal with it now, as that is a subject for itself. Now that we are acquainted with some of the basic terms, you see how by just getting an IP address of a device, we more or less, by default, are given a sea of useful information. For example, you can, from an IP address, you can conclude where the device is located physically. I mean, you not only a country, figure out from which country is it coming from which city, from where in the city, etc. You have websites today that you can go on to, and you can type in an IP, and it will give you its location. It won't be as precise, but it will be good enough, trust me. And if we just figure out, if we do a scan of the system, and if we figure out which ports are open, on which ports is the system listening, we will be able to conclude in a good amount of cases what applications are running on the server or wherever. Anyway, next up we need to go over the OSI model briefly, and immediately after that we will actually start using Wireshark. We will first go through the installation, and then we're going to configure it, and then I'll show you the various options that it has, and most importantly of all, we need to go over traffic capturing and filtering. In any case, thank you for watching. I bid you farewell. Till next time. Now that we are acquainted with some of the basic terms, you can see how by just getting an IP address of the device, we can get a large amount of information. For example, with that IP, you can figure out the physical location of that device. You have websites today, you can just type in an IP address and it will give you a relatively precise physical location of that IP. And by just figuring out which ports are open, we are able to conclude in a good amount of cases what applications are running. All of this will be of great use to us later on, primarily because we will do IP filters and port filters and protocol filters. So all these things will come together once we actually start up the Wireshark and start using it. Next up, we will go over the OSI model, but briefly, and immediately after that we will actually start using the Wireshark. First we will do the installation, configuration, and then we'll actually start capturing network traffic, analyzing it, and so on and so forth. In any case, thank you for watching. I bid you farewell till next time. Hello everybody, and welcome to this tutorial. Here I will show you how to install and set up Wireshark. Before I begin the installation process itself, let me just say a few words about the environment that I'm using. So my operating system is Linux, to be more precise, Fedora 20. It's a 64-bit system, so you will see how this comes into play when we go into packets. So I'm just going to exit root mode to make a point here, and I'm going to clear the screen. In Fedora, which is a Red Hat based distro, we have a yum, which is basically your installation manager. That's the best explanation I can give for it. And we go ahead and type in search Wireshark, and every package within the repositories that are to be used that has Wireshark name in it be it in the actual name of the package or in the description of the package, will be displayed here. You can go ahead and skip these things immediately. So you see development headers and libraries. We don't actually need that. We need the program itself. So down below we have Wireshark for 32-bit architectures and for 64-bit architectures. If you're not sure which one you are using, you can just type in uname -all, and here you go. Just look for this one or for this one here. So Linux localhost local domain kernel Fedora 20, and here we go. x86_64. No problems. Now we know for sure that it is a 64-bit system, and I'm just going to go ahead and begin the installation process, but I am going to install Wireshark GNOME even though I am using a KDE desktop. There's GNOME desktop, there's KDE desktop, and there are a ton of other desktops for Linux distros. I have found out that these two have some serious problems in them. I mean, they don't work well with Fedora in any case. So just go ahead and grab this one, copy it, and go ahead and type yum install and paste this. Oops, what has happened here? It says you need to be root to perform this command. So as I said previously, I exited root deliberately, just to show you that you need to be root or have such permissions as a regular user. So you need to be a super user or something of a kind in order to be able to perform any sort of installation from the repositories on the system. Just go ahead and type su. You can also type sudo su. I don't know, depends on the distro that you're using. I just type in su and type in the password. There we go. I'm just going to change directory, not that that makes any difference, but I did anyway. Clear the screen and go ahead and type again yum install Wireshark. No, I don't actually need to type it. I have it here. So just going to paste it, enter, and it's going to begin the installation process. It's going to give you a ton of information, but I wanted to stop it here for a reason. I didn't give it the -y command to go ahead and skip through this. So you can see that it is installing Wireshark GNOME, and it is automatically installing for its dependencies as well. So just type in Y here, press enter, and the installation process will go ahead. While this is happening, just in case you are using some other distribution or something of a kind or a different operating system, so just gonna clear the screen out here, and in case you're using a Debian based distribution, you would type a command that looks like this. So apt-get install and then the name of the package, like Wireshark. I think if you just type in Wireshark, it's gonna find by default the one that you need, especially in Ubuntu if I'm not mistaken. But in case you're not using Linux, in case you're using Windows, you need to go out to the web, type in, well, I'm just gonna type it in here. I have no idea why, but just a habit, I suppose. Wireshark. Go ahead and search for it and see what comes out. So the first one is the official website. Go ahead, visit it. Let me just expand this across the screen. So the website is www.wireshark.org. And on their website you have a ton load of stuff. I mean, you even have some videos here and stuff of a kind, but most important, even books, but most importantly of all, as I wanted to say, is the download button. So you press the download, and there you go. You have Windows installer, two of them for 62 and 32-bit versions, and you even have like portable apps. Wireshark is a portable app. Have it for OS X, etc. If you are uncertain, I mean, a lot of people out there will scream at me for saying this, but if you are uncertain which architecture do you have, is it 32-bit or 64-bit, and you don't know how to check it in a specific point at a specific point of time, even though you can just go online and type in how do I check the architecture on pretty much any operating system out there. But in case you're lazy and you don't want to find out, or you don't know how, you can always install 32-bit versions and they should work 99% guaranteed. The process does not work vice versa. 32-bit can work on 64-bit, but 64-bit cannot work on 32-bit. This what I've just said does not just apply to Wireshark. This is in general. So pretty much for all the applications out there. I'm gonna go ahead and close this browser. I do believe that the installation process is complete. Yep, there we go. So we get a lot of information here along with the installation process. So it's installing this, and verifying the installation. So it says installed Wireshark GNOME and dependencies installed Wireshark x86-64. So you do need the GNOME part in all of this. Anyway, we're going to start up the Wireshark, but we're going to start it as root. Now, why is root? Why can't we just start it as a regular program from an ordinary user? Well, you basically can. You need to extensively configure it, but even so, you will be prompted for a root password, and some of the services that run in the background that you don't actually notice will have to run as root. Generally, some people claim that it's a security issue, but I mean, if you are the only person that's going to use that computer, if this is your computer, obviously you're not going to do any sort of shenanigans or anything like that. And just go ahead and start it as root, and don't worry about a thing. So Wireshark, just start it. It's an open source application, so you know that there is nothing, even though you probably cannot understand the code, you can rest assured that there is nothing malicious in it, primarily because pretty much everybody out there can see it. So certainly there would be somebody out there screaming if there was something wrong with it. Anyway, there you go. Wireshark is installed and ready to be used. I'm just gonna go ahead and start a live capture to do a small demonstration before I wrap this up. So we have, look at the amount of interfaces it has recognized on my computer. So we have Bluetooth, I don't know which ones are these, but anyway, this is for the virtual. You can even capture traffic from your USB. Unfortunately, my laptop has only three USB, so I have to use extensions, etc. So you even have an option to listen on any of these interfaces. So if you don't know, or if you don't want to bother finding out which interface you are using, through which interface are you connected to the net, you can just listen on all of them, and whatever traffic comes, you can capture it. But I don't really recommend that. If you're troubleshooting an issue, or if you are really looking for something specific, there are uses for this option. But what I generally like to do is simply go ahead, open up my terminal. This is one method that you can use, but there's another one which I will show in a moment. So just go ahead and type in ifconfig, press enter, and as before, you have a list of interfaces here. I know that I'm using P8P1 wired interface primarily because my network cable is plugged in and my wireless router is turned off for the moment, so I can't even connect to it even if I wanted to. So you can see I don't have an IP address assigned here. This virtual interface, this is just for traffic from virtual machines. None of them are up and running. I know that it's not loopback because that's only for local communication. That's only for local things on the computer itself. And you can see that the internet address has been assigned. You have a netmask, you have a broadcast. Down here you have numbers. These values are not empty, so packets are passing through this. But a much easier way to figure out which interface you are actually using would be to go to your local network manager. Mine is in upper right corner. Just open it up, and you can immediately see it says P8P1 connected, active connections, in the active connection list. And down below you have available connections, to which I'm not connected. Where your network manager is, it really depends how you've configured your desktop. By default, I do believe that it's in bottom right corner, and you can click on it, open it, but I'm sure you won't have any problems finding it. That's the easy part. Anyway, once we know that, once we figured out which interface we're using and where do we want to capture traffic? We just find it here. So there we go, P8, P1. One key thing to note, if you're using some other distro, for example, a Debian-based distro or something of a kind, you're probably going to have markations such as these for your interfaces. ETH0 and ETH1. Naming conventions are not the same, so yeah, that can be a bit confusing, but no problems, you'll still be able to figure it out. The names won't be exactly as mine are, but you'll still be able to figure it out just by looking at it. ETH0 usually represents the wired connection, and ETH1 wireless connection, as far as I've seen anyway. It doesn't have to be the case, but usually is. Just check it out, see it, and as a final resort, you have your network manager where you can be absolutely certain. So P8, P1, you click on it, you mark it, it needs to turn blue. It needs to turn blue like this, and there is this green glowing shark tail in upper left corner. When you go over it with a mouse, it says Start New Live Capture, and that is exactly what we shall do at this point of time. Just click on it, and we should start getting in packets any moment now. There we go. So in the next tutorial, I will explain the features of Wireshark. So what these buttons are doing, what you can do with these menus, what is where, but most importantly of all, this will be our working space. This is where it says filter. This is where we shall apply various filters to basically seclude portions of traffic or to only get certain kinds of traffic. Because look at this now. I mean, you're getting all sorts of information, all sorts of protocols coming in on all ports, and it's just chaos. This is basically, one could interpret this as white noise because you cannot distinguish relevant information. But what you can do is apply filters and then see what you want to see, or see segments of that. Just before I finish, I just want to show you. So look, it's installed, it's set up, it's running, everything's fine, it's working, but if you install it for the first time, this issue can arise. So this bar, or this window, let me just try to grab it. There we go. Come on, come with me. Up, 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 there we go. It climbs up all the way to the top. So your first Wireshark can look like this. This lower window is completely expanded and it's blocking the upper one. So you can't see it. And you might think, oh man, there's an error, or I didn't do the installation in a proper way or something of a kind. It took me about 20 minutes to figure it out, a bit of an annoying thing. Basically, just pull it down. That's it. I don't know, a bit of an annoying thing. I think it's fixed with updates, but it tends to happen from time to time, and you don't know what's wrong with it. You just need to tamper with it a little bit and then figure it out. That would be it. I thank you for your time, and I bid you farewell till next tutorial. Hello everybody, and welcome to this tutorial. Today I'm going to be talking about a command line interface for Wireshark, but before I go into all of that, let me just say that we went over the first portion of our course, and we have learned some of the basic and fundamental things needed for us to use Wireshark and to successfully capture traffic with it. Now from this point onwards, we will start to deal with semi-advanced things, and we will move on to advanced things. If you haven't watched the first part and you've never encountered Wireshark before, make sure to tune in there and have a look at those videos, and then come here, because here I am not going to be using the graphical interface for Wireshark. Now you might wonder yourselves, why should anybody not want to use the graphical interface? I mean, surely it is easier. Well, yeah, theoretically it is easier, primarily because people are used to just clicking places instead of typing in commands. However, not all environments will support graphical interfaces, especially server environments. And that is most likely where you will need to go and capture traffic. Routers, for example, will not support graphical environments, but you won't be able to install a Wireshark on a router anyway. For routers, I will have a separate section where I will explain how you can capture traffic be it on your local router inside of your home, or on some remote router within LAN or something of a kind. In any case, today I want to focus on this command line interface, and I want to show you how you can actually do this within an environment that doesn't have a graphical interface at all, that does not support, for example, some sort of a server such as a web server, I don't know, a DNS server or something of a kind. You won't be able to do anything else other than to use the command line interface, or there is actually another option which is quite common these days as well. You can set your server up in such a way that it forwards information to a certain place, and that certain place can be your computer workstation with a Wireshark installed, and in such a way you can capture traffic as well. That is what they mostly do on routers. They set up one port on the router to which all data is copied and transmitted, and in such a way you can also monitor traffic. But with that we shall deal a bit later on. For the time being, I just want to introduce you to this command line interface, and I want you to see how it works, what are its capabilities, and what you can actually do with it. One more thing to note is that you can have an interaction, you can have an active interaction between your command line interface and your graphical interface. For example, you can create a file on a server somewhere that doesn't have a graphical interface, and then you can use a command line interface from Wireshark to capture all the packets, put them into that file. Afterwards, you can either send the file via mail, or you can save it to a USB and bring it physically to a different computer or something of a kind where you have graphical interface. Afterwards, all that information that is saved within a file, pcap file, that's the extension for Wireshark files. It's just .pcap. You have different extensions like .txt or .docx or something of a kind. Well, for Wireshark files, it's .pcap. So P and then cap, CAP. Anyway, you can import that file into Wireshark, the one that actually has graphical interface, and analyze it there. Apply filters during. It's not going to be a live capture session, but you're going to have a file which you will be able to filter out, see the packets, etc., and so on. I will show this in greater detail as we progress through this tutorial, but for the time being, I just wanted to introduce you to the command line interface of Wireshark. So, without further ado, I'm just going to go ahead and type in tshark. Oops, that didn't work out. So tshark, which is a command for Wireshark command line interface, and I'm going to type in --help, press enter, and this is going to give us a list of possible arguments that we can pass to a command. Let me just explain this a bit better. So tshark is a command, and then you can use dash, and I don't know, press -h. You're just passing arguments to this command. These arguments can vary. I don't know, you have -h for list of all the options that you can list of all the options that you have. You can have -w to write the output to a file or something of a kind. Worry not about it. I will go pretty much through all of these arguments separately. I will explain in detail what each one of them does, and by the end of the day you will be able to use command line interface successfully without any problems or anything of a kind, and you will understand the power of it, what you can do with it, and where it will excel the most. Because speaking in all honesty, you will need the command line interface. Whether you like typing commands in or not, eventually at some point of time as a network administrator, you will have to use it, primarily because you will encounter these environments where you simply don't have any sort of graphics of whatsoever. Be, that being left aside for the time being, I'm just gonna go ahead and scroll upward, and you can see all the incredible amount of arguments that you can actually pass, ranging from filtering the outputs to giving flags when to stop the capture or even when to start the capture. So for example, you can specify start the capture in an hour, capture packets for, I don't know, 30 minutes, stop, then repeat the process again in 2 hours or something of a kind. The possibilities are practically infinite, which is very nice because it fits tools. It can be made to fit tool situations, so to say. And here we go. I have typed in tshark help here, and the listing begins from there. I don't know, you have some copyright things here regarding Wireshark. It's completely open source, so you don't have to worry about that. You see the copyright here says that it doesn't claim responsibility for the use of Wireshark and that it doesn't guarantee that it's fit for any particular purpose. So if you don't succeed doing anything with it, it's not their problem. They didn't guarantee anything. But more likely than not, it will come in handy and be very useful in a lot of situations. Anyway, in the follow-up tutorials, I'm going to explain these commands, these arguments, what they do. We're going to use a lot of them and demonstrate how they can be effective in various situations. Thank you for your time, and I hope I'll see you in the next tutorial. Hello everybody, and welcome to this tutorial. Today I will be talking about Nmap and how you can analyze its traffic with Wireshark. So Nmap is a tool for scanning network. You use it to scan networks, basically. It can give you a great deal of useful information. For example, if you're in LAN, it can give you MAC addresses of the machines that are within LAN, provided of course that you know the IP addresses. But even if you don't know the IP addresses, you can just scan the entire subnet or something of a kind. It can also determine which operating systems are running on remote machines, whether they are in LAN or outside. It doesn't matter. It will conduct a scan. But primarily it can tell you what ports are opened on the system, and if it tells you what ports are opened on the system, you can conclude a great deal of things from that. For example, you can figure out which services are running, and you can assume which operating system is running there because you have some default open ports on some systems, and in such a way you can get more information. Now, you shouldn't scan a system that you do not own or have an explicit permission to scan, because that is not permitted. However, today, within my lab environment, I will be scanning my own virtual machine, and I will show you how you can actually how you can monitor the traffic, and monitor, more importantly, how you can monitor the size of the traffic. Because the less packets you have, the lower the probability is that your scan will be detected, and you have a lower chance that the firewall will actually stop your scan as well. Now, this is very important for people who are into penetration testing. They tend to use this method, basically just scan a virtual machine with Nmap and then have Wireshark monitor the scan, and in such a way see which parameters, which sort of scan of Nmap will generate the least amount of traffic. In any case, as I've said before, people in pen testing who do this, they have a permission to scan the systems and to perform these kind of tasks. So unless you own the system or have a permission to scan the system, do not do it, as it is not permitted. Anyway, what you will need for this tutorial is Nmap installed on your system. On Linux, it's pretty much easy. There isn't that much science, there isn't really that much thinking to it, so to say. As you can see, I've just typed in here yum search nmap. This -c option is basically just tells my packet manager yum, do not perform updates at this time, just try to find package nmap. You don't need to worry about that. And as soon as you type that, you get a output down here. So I don't know, you have some sort of things here which you're not really that interested in. This is also a very, very interesting tool. It says Nmap's NCAT replacement, but nothing is ever going to replace NCAT. I mean, seriously, like, that's one of the tools that has been around for quite a while. And if you don't know what it is, I strongly advise that you get familiar with it. That is one small task that I have for you if you wish to learn more about networking, monitoring networks, and troubleshooting them. NetCat is a fantastic tool. It allows you to connect on pretty much any port in any way. It supports a great deal of protocols, and it is fantastic for testing. It's completely free. You don't need to pay for anything for it. It's open source. So yeah, I'm not selling anything or anything of a kind. Just have a look at it. It's going to be, if you plan to do something with networks or have a career, you're definitely going to need that tool. Anyway, coming back to the subject, down below you have nmap.x86_64. It says Network Exploration Tool and Security Scanner. Basically, that is precisely what it is. as I said, it just scans the networks and it gives you a lot of information. If you wish to install it, just type in yum install and then nmap, nmap, and there you go. That should do it. You will install whatever you need to. That will install the package without any problems. As you can see, I've pressed tab with a wrong argument and it has given me some rather weird options, but irrelevant. You just type in yum install space nmap and it's gonna run through. If you just go ahead and clear the screen. Now I do have my virtual machine set up here, one of them anyway. It's just a different edition of Fedora, the next one, 21, where I'm testing it. This is a live boot, not an actual installation. That's why it's running a bit slower. So its IP address is 192.168.1.4. And that is the IP address which I wish to scan and monitor the traffic. So let me just go ahead and start a live capture on my wired interface P8P1. Apply my filter here. So you should know this filter by now. Apply. There we go. So there isn't any traffic now. I mean, there is traffic, but nothing is really being displayed because I have told it that the source IP address has to be me. Basically, this is the IP address of the machine that I'm using at the moment. And the destination IP address has to be the virtual machine, which is this is the IP address of the virtual machine that you've seen a moment ago. So as you can see, there is no traffic now, nothing of a kind. Down below, you have packets, the amount of packets, it says packets 21 and displayed 0. Excellent, that is precisely what we want. Now we can conduct our scan. So let's begin with the basic fundamental nmap scan. I'm just going to go ahead and type nmap and type in the IP address. So 192.168.1.4. And remember to pass the option double V. So not W, but double V. You can also say 1 or 2. Basically, this defines the verbose output. How much information do you want the program to give you in regard to what it is doing at the moment? And I always like to be informed, so I always pass the double V here. It is quite in handy. It's quite in handy because I don't know, sometimes nmap scans will take a while and you will just see a blank screen, you won't see anything happening, there will be no progression bar or anything of a kind, and you will think, oh, it's bugged or something of a kind, and you will interrupt the scan, and then you will need to do the whole thing all over again. Like this, you can see what it is telling you. There we go. It says starting nmap, initializing rping scan, scanning 192.168.1.4. And it's clearly telling you what it is doing. There we go, the traffic is now being generated, and we have a lot of things here that are going back and forth. And there you go, the scan is finished. This is a very fast scan, obviously, because this is all in LAN, so the scans can be conducted rather fast. But look at down here where it says packets displayed. It's the the middle of the screen in the bottom. It says that I have 1500 packets approximately, and that my nmap scan has consumed 1220 packets. That is a huge amount. I mean, this is bound to be detected for sure. If there is a network admin on the other side, they will notice this scan, no problem. So we need to actually work on reducing the size of our nmap scan. One of the first things that I'm going to do, aside from clearing my screen and making a more neat working environment, is go ahead and type in nmap --help. Press enter, and this is gonna prompt a help bar. Let me just expand this a little bit for you so you have a better overview, and repeat the process because terminal does not resize the text by default. And so here we have some other options in the example. It says these are just miscellaneous arguments for Wireshark itself, but we have a ton load of other options. One of the most, look at how many of them there are, pretty much the same procedure as with T-Shark. You type in help and you figure out what is where. So this is one of the more one of the options that people would use on more frequent basis. So dash O. So let's try dash O and let's see how much traffic will that generate. Before I do, I wish to reset my capture, as I don't want this, as I want to see exactly how many packets be will be recorded. So let me just find it. Yep, there we go. And I'm gonna pass dash O, capital O, press enter. Here we go. It's initializing the scan, and you can see that there are packets already streaming in. It says 57, 50, almost 60 there. We'll see how much it will be, how much packets will generate in total. So not that, not, oh, it's still going on. It's still going on. It stopped. And this is not good either. So it says almost 1600 packets. This is more than our previous scan, but this is something that you would need to do from time to time on your network as a pen tester, as a network admin, to figure out what is going on, what system is being used on the other side if you can't physically go over there or something of a kind. But as a pen tester, this is not good. It's 1600 packets, and again, you are bound to be detected. But these are just some basic options that you can pass. In the follow-up tutorial, I will explain in great detail how you can conduct stealth scans, and you will see how Wireshark, when it monitors the traffic, there will be a significant reduction of the amount of packets transmitted. In any case, I bid you farewell, and I hope that you've enjoyed the tutorial. Hello everybody, and welcome to this tutorial. Today I will show you how you can conduct a remote capture of a machine that is not necessarily within LAN or within the range of your wireless card. In the previous tutorials, I have shown you how you can actually conduct a remote capture of all the traffic that is up in the air around you, provided of course that it is in the range of your wireless card, and provided of course that you do have the necessary decryption keys. This was done through the managed mode of a network card. We will not need it in this tutorial, primarily because the machine from which we will be capturing traffic can be anywhere else in the world. So we are capturing traffic over it that will be sent over the internet to us. What this means is that you can be in Germany, let's say in Berlin, and the other machine can be in Tokyo, and you will be able to stream the network information over the internet to your machine in Berlin and capture and analyze traffic in Wireshark there. Now, depending on the amount of traffic and depending on the available bandwidth, this can be either slow or fast, depends how you do it, but it is possible to do it, and that is what I want to demonstrate today. Now, there are prerequisites. There are a few things that you're going to need if you wish to be able to fully follow through this particular tutorial. The very first thing that we will need is a protocol called SSH. Now, SSH is a tunneling protocol, and it will ensure that all the traffic transmitted from the machine in Tokyo to machine in Berlin will be heavily encrypted. So even though somebody could be in the middle of your communication, in the middle of the communication between two machines and capture the traffic, they won't be able to do anything with it. I have shown you in the previous tutorials how encrypted traffic looks like, and as you could have seen, there isn't much that you can actually do with it. You can extract bits and pieces of information, but you cannot actually get the data itself without the decryption keys, of course. And the chances of somebody getting the decryption keys are very slim to none, and of breaking the encryption. And in order to break the encryption without decryption keys, I mean, it would take an eternity of time to brute force it or something of a kind. Anyway, I will show you how to install this. You will need this on both machines, not just on one. So key thing to note here is that you will need it on both machines. Fairly easy to install. I will show it to you in the follow-up tutorial. But for the time being, you will also need you will need additional things. So TCP dump is next. TCP dump. It works in a similar fashion as Wireshark's command line, tshark. You just pass arguments to it and it can capture traffic, filter it, pipe it, etc. This will only need to be installed on a remote machine where the capture will be performed. You will not need this on your destination machine, as you will be using Wireshark there. I will show you how to install TCP dump as well, but on Linux machines, TCP dump in all likelihood is installed, like 90% chance. And I am using TCP dump primarily because in 90% of cases it will be installed on Linux machines. This is for ease of use. You can also use Tshark here, but most of the time you're not sure, and in all likelihood it will not be installed on the remote machine. I have shown you how to install Tshark as well, so that's not a big deal. Basically just install Wireshark and it comes packaged with it. But we will be using TCP dump on a remote machine, and you will not need to install it there, of course, as it will be installed. But I will show the installation procedure just in case that it is not installed. You will see the command for it is pretty simple. There won't be any complications there. Next up, you will need to be able to configure Wireshark in order to capture traffic not on any of your interfaces. Rather, instead, we will need to create a named pipe for Wireshark. It is a file from which it will extract information and display it in the graphical user interface, where you will be able to analyze it, filter it, and do pretty much whatever you want with that. I will show you how to make that file. Pretty simple as well. No complex stuff there. The biggest problem is establishing an SSH connection and making sure the data is encrypted and that there is a steady flow due to bandwidth and such things. So we will need to pass some extra arguments to TCP dump in order to ensure that our data is streamed in a proper manner. Now we will also need to configure SSH just a bit on one end, so on the source machine in Tokyo. That is where we will need to configure SSH to allow for root logins, because keep in mind, for all these operations you need to be either root, or you need to have sudo or your user needs to be in sudoers file, so it can have root permissions. In any case, that would be it. This was an introductory video to what we shall do here. If you don't have the prerequisites, you can try and get them on your own. Try to do it. As the installation procedures are the same with any other packet that we've installed thus far, you can try doing it yourselves. I would strongly advise that you do so. And then in the next tutorial, I will show you how you can actually do this. So if you have had any problems with it, you may refer to the tutorial and see, okay, I didn't do this the right way, or I didn't do that the right way, and in such a way you will be able to learn better. So I bid you farewell, and I hope to see you in the next tutorial.